So we have understood what is probability. We have understood that probability is actually the total number of favorable outcomes divided by the total number of possible outcomes. But the most important thing is that the probability of happening of any event, let's say probability of happening an event A, is actually lies between 0 and 1. It means probability of happening of any event, like if you take any event, the probability of happening that event always lies between 0 and 1. That is 0. So its probability is either 0 or greater than 0, and either 1 and or less than 1. So the probability cannot be more than 1 or less than 0. If the probability of happening any event, let's say probability of happening event A is actually 0, it means that it is an impossible event. Impossible event means that event cannot be possible. And in the same way, if probability of happening any event is actually equal to 1, it means it is a sure event. Sure event means that event will happen definitely. Means there are 100% chances of that event to happen. So that event is known as the sure event, and the probability of that event is always equal to 1. And if it is an impossible event, that means the probability of that event is 0. So now we have understood that what is the probability, basic idea of probability, and between which values the probability lies. Now we'll see some important thing about the probabilities. Like let's take for one example first is like if I say that the probability of happening rain today will be 70%. So it means the probability of rain, as I have said, is actually 70%. 70% means 70 divided by 100, or if you can say 0.7. So probability of happening rain is 70%, that is 0.7. It means the probability of not happening rain will be, how to find out the probability of not happening rain? So not happening rain will be finding out, as you can easily understand from the question is that probability, if the probability of happening rain is 70%, it means the probability of not happening rain will be 30%. So it means you can directly write this 30%, that is 0.3 is the probability of not happening rain today. So this you can directly find out, as you know the probability of happening rain. So as you can see that the probability of happening rain is 0.7. So if you want to find out the probability of not rain today, you can directly subtract the probability of happening rain from 1. So you will get the probability of not happening rain today, that is 1 minus 0.7. 0.7 is the probability of rain today, and if you are subtracting it from 1, you will get 0.8, 0.3, that is the probability of not happening rain today. So it means probability of happening any event plus the probability of not happening the same event, and it is denoted by a and bar. So in this way you can denote the probability of not happening any event. So it means that the probability of happening any event, that is a, plus the probability of not happening the same event, summation of both these things will always be equal to 1. So it means 1 denotes the 100%, that is probability of happening an event, whatever will be the probability of happening event, if you subtract it from the 100%, you will get the probability of not happening that event. It means let's say let's repeat the same example of rain. That's probability of happening rain is 70%. It means that the probability of not happening rain is 30%. So that summation will give you the 100%, or that probability will come as 1, because it is 100 divided by 100, that is favorable outcome upon total outcome. So probability of both the things will always be 1. So as you can have already seen that the probability of happening rain is 0.7, and the probability of not happening rain is 0.3. If you add both these terms, you will get 1. So this shows that the probability of happening any event plus the probability of not happening the same event is always equal to 1, and this property is known as the negation of event. This is known as the negation of event. Now we move on to some examples based on the probability, and we'll see how to solve those examples of the probability. Let's take the first example. In the first example, let's take an example of coin. We start with the coin only. So let's take the example of coin. Suppose there are two unbiased coins. Unbiased coins means one is on one side there is tail and the other side having head. So there are two unbiased coins and both are tossed simultaneously. So two unbiased coins are tossed simultaneously. So when two unbiased coins are tossed simultaneously, definitely there are some outcomes. So first it is given that there are two unbiased coins who are tossed simultaneously. So accordingly we have to find the probability of getting first two heads. So as you see in the question that it is given that two unbiased coins are tossed simultaneously. So accordingly, they have asked what is the probability of getting two heads when both coins are tossed simultaneously. So first we'll see the sample space, or first we'll see the all possible outcomes that we'll get when we toss two unbiased coins. So one outcome can be let's say on both coins you will get head. Okay, the second outcome will be, let's say on the first coin you will get head and the second you will get tail. In the same way, third outcome will be on the first coin, let's say you will get tail and the second you will get head. And the next outcome will be tail. It means that on both the coins you will get tail. So there are four possible outcomes when two coins are tossed simultaneously. So these of these four possible outcomes, in the question it is asked, we have to find out the probability of getting two heads. So if you can see out of these four outcomes, there is only one possibility where we are getting two heads. So it means the probability of getting two heads will be equal to total number of favorable outcomes. Now as you can see, out of these four possible outcomes, there is only one favorable outcome, because in only one outcome we are getting two heads. So there is one favorable outcome, so that is total number of favorable outcome will be 1, and divided by the total number of possible outcomes, and as you have already seen that the total number of possible outcomes is 4. So probability of getting two heads is equal to 1 by 4. So in this way we have to solve the problems on probability. Now let's take the second part of this question is, we have to find out the probability of getting, let's say, at least one head. So again, as we have tossed two coins, we have to find out the probability of getting at least one head. Again, we'll see. Look at the sample space. Sample space will be head, tail, head, and tail. So these are the four sample spaces, or four elements of the sample space, and we have to find out the probability of getting at least one head. At least one head means we have to find out in which cases we are getting either one or more than one heads. So it means that we have to find out the probability of getting at least one head. So if you see these four outcomes, out of these four outcomes, there are three cases where we are getting at least one head, that is either of one head or more than one head. So head we are getting two heads, that is at least one or more than one. At least one, that is either one or more than one. Now and second, head tail, in this again we are getting one head. Tail head, again we are getting one head. And in the last sample space, tail we are not getting head, so we will not consider that element of the sample space in our favorable outcomes, because in the favorable outcome we have to see only those outcomes in which we are getting at least one head, and there are three such possible outcomes in which we are getting at least one head. So probability of getting at least one head will be total number of favorable outcomes. So total number of favorable outcomes will be 3, because in 3 cases we are getting either one or more than one head. So there are 3 cases, so that is total number of favorable outcome will be 3 divided by the total number of possible outcomes. The total number of possible outcomes will be 4. So probability of getting at least one head will be 3 by 4. Now, so in this way we have to actually analyze the question properly accordingly, and then we have to use the formula for the probability for finding out the probability. Now we'll move on. The next part of this question is again, now we have to find out the probability of getting at most one head. At most one head. So how to find out the probability of getting at most one head is, again we'll first look at the sample space. So as you know that sample space has 4 elements or 4 possible outcomes. So now we will look at the cases in which we have to find out the probability of getting at most one head. At most one head means that there can be only one head, or there can be less than one head also. But it cannot be more than one head, because at most means at the maximum you can select only one head out of the two coins, out of the two coins. So it means first we have to analyze the all possible outcomes. Accordingly, we'll see in which cases we are getting at most one head, or let's say one head or less than one head. So as first look at the first possible outcome, that is head. In this case we are getting two heads. So we will not consider this element, because we have to select only those elements in which there are at the max one head but not more than one head. So first element will not consider. In the same way, second element we can consider, third we can consider, and again the fourth, that is tail we can consider, because at most means it can be zero heads also. So in the last element there are two tails, so it means there are zero heads. So we'll consider that event also. So in this it means that the probability of at most one head will be equal to total number of favorable outcomes. Now as you can see that favorable outcomes are again 3 divided by the possible outcomes, that is 3 by 4 is the probability of getting at most one head. And let's take one more example of this of these two unbiased coins. Now again we have to find out the probability of getting no heads. So how to find out the probability of getting no heads? So again we'll consider the sample space first. So in the sample space, as you can see in the question, it is asked that we have to select only those cases in which there are no heads. And if you can consider this sample space, there is only one element or one case, such case in which there are no heads. Otherwise, there are at least one head in the other elements. So probability of getting no head will be equal to total number of favorable outcomes. Now, out of these four possible outcomes, there is only one favorable outcome, because in only one case we are getting no heads. So one is the favorable outcome, total number of favorable outcomes divided by the total number of possible outcomes, which is equal to 4. So probability of getting no head will be equal to 1 by 4. So in this way we have to actually analyze the question properly accordingly, and then we will be able to solve the question.